Hello everyone, and welcome to another Stat385 video. So in this video, what we're going to do is discuss data and Tibble, which is a data structure within the tidyverse, which we'll also discuss, that is very, basically mimics the behavior of a data frame. It's very similar to a data frame. And then I should also say that, as we say in the welcome video, that we are now going to be transitioning to working with packages in the tidyverse for wrangling data sets to be useful in some sort of analytic step. So before we've done programming, like working with objects and functions, creating functions, working with apply functions, stuff like that. And now we're going to be talking about programming in a data analysis context, even though in this class, we're going to restrict ourselves to programming rather than actually doing data analysis. And then hopefully the other statistics classes you take will focus on data analysis. Okay, so this is a slide deck that I've borrowed from David Dalpiaz. So thank you, David. Let's get into it. Okay, so... Right, which I just sort of touched upon. So far in R, we have worked with objects and functions. Remember, everything in R is an object. Everything you do in R is a function call. So we've discussed atomic vectors, lists, data frames, functions, mostly the first three when we talk about objects, but a function technically is an object. And then we can use those as input into functions, which then do something and then output some other object. Okay, so this is what we've done so far. Okay, so now we're going to, I guess, it makes sense to, as we move into the tidyverse and discussions about programming with respects to, or in a data analysis context, it's important to discuss different roles for actually working with data. So many of you in the stats program are probably familiar with the term data science or a data scientist, which we will use as a term to include statistician or many other different job descriptions that you could imagine, where the primary aim is to transform data into insights. I should be a little bit careful here with data scientist. Data science itself as like a separate or different discipline than statistics may not necessarily consider the broad level of or the broad form of transforming data into insights, but nonetheless, I think it is fairly reasonable, definitely in the world of industry, that this title is appropriate for that idea. Okay, transforming data into insights. And then you have, on the other hand, a data engineer, which is transforming data into data, which of course seems very strange at first glance, but the idea with that is that you may have some sort of process which is collecting some, like actually collecting measured data in some sort of raw, not useful form. And a data engineer would then, transform that into data that would be useful for a data scientist. And also data engineers are interested in how data is stored, what is the best way to store data, what is the best way to access data, that kind of stuff as well. So these are distinct roles, and I'm going to emphasize them here because as we move throughout the rest of the semester, we'll sort of live between both of these worlds. However, we won't necessarily focus on data analysis, but rather like how to develop a set of tools that could be useful for data analysis would be the way to think of it. Okay, so first of all, what is data? I'll just, oh, wait, did I skip? Okay, actually, nope, I went too far. So what is data? So you can pause the video, read these definitions. I don't think these definitions are necessarily complete. So, if we have the Merriam-Webster factual information used as a basis for reasoning, discussion, or calculation. Okay. I think that it makes sense to talk about data in the negative, like what isn't data. And what I like to say is data is anything that cannot, or if it can't be measured, then it isn't data. And I think that I don't want to get too far in the weeds on this, because this is actually a description that I think is also useful for statistical research to keep in mind. So it's actually a fairly broad definition that actually would hold in a lot of different contexts. So in short, data is, or if it can't be measured, then it isn't data, would be a way to think about it. And if it can be measured and can be tabulated and stored, then it is data. Yeah, I really want to go down this rabbit hole, but it's not really, it's beyond the scope of this course, as we often like to say. Okay, so in particular, we will be working with tabular data. And in tabular data, a variable is going to be some quantity, or something that you can measure. And then a value is going to be the state of the variable when you measure it. And an observation will be a set of measurements made for one particular, I usually say individual. And when I say individual, I could mean like an actual physical subject or just some time point. And then tabular data is going to be a set of values, each associated with a variable and an observation. Okay, so this sets up, this is actually going to set up the data structure referred to as a Tibble. So that's kind of the direction that we're going in. Okay, so tabular data is going to consist of rows that represent observations. So this is what I usually say, like a row is one subject, technically observation, and then you have a bunch of variables collected on that particular subject. And then each one of those within the rows is a value. Of course, we have more observations, so we have more values filling out the whole thing. So in this sort of description, I've kind of given away what the next one is. Columns are going to represent variables, features, attributes, whatever. And those are the things that you collect on each observation for some purpose. And then the cells are the values themselves. So, okay, so we have rows for observations. We have columns for variables collected on observations, typically in the data analysis context, and cells, which just represent the values in the tables. Okay, so typically in statistics, we say that we have n observations, p variables type of thing. So we have n rows, p columns, and that sort of tabular data formulation of that concept. Okay, so now on to tidy data. So these are the rules that make a data set tidy in this, as we switch to the tidyverse. So each variable is a column, each column is a variable, each observation is a row, each row is not, okay, so each value is a cell and each cell is a single value. Okay, so these are the rules that will define a tidy data structure. And, we can think of the columns themselves being, columns are variables, observations are rows, and then the individual cells specify the values of this data structure. Okay, so that specifies tidy data. Don't necessarily, okay, so this is, in the book that we reference, R for Data Science, there's a whole, I guess, I don't want to say life cycle, that's the wrong word, but just schematic representation of what a statistical analysis, or what an analysis, I'm saying statistical analysis in the context of, this discipline, this department, but I guess an analysis of data from start to finish. So where you would have some data existing on your computer or in the cloud or whatever, and then you would import it into the programming language that you're working with, and then you would tidy that data into like an initial usable form. And then you may consider, in an analysis context, transforming the data further, then visualizing it, then constructing some modeling and iterating this process until you have come to a acceptable, useful analysis that can elicit some insights for some interested party, be it a scientist, researcher in general, or or some industry professional, or your boss, I guess, this is to put it shortly. And that's the communication step. Okay, so we're not going to be in this class working in the loop here, the transform, visualize, model, or the communicate, but we need to develop the tools to make those things possible. That's a big part of statistical programming, and that is what we are shifting to within discussing programming in the context of data analysis. Okay, so we can think of maybe a more basic representation of this life cycle, which we have storage and transport. So that is like where the data is physically stored. And then we have this import step, and then programming on the tabular tidy data that we would have. And then here we can think of for like working on this tidy structure to maybe filter out rows that aren't useful, or select some of the columns, subset some of the columns, subset some of the rows, stuff we've seen before, or create new columns from existing columns, that kind of stuff. Maybe converting objects of certain types to other types, finding, detecting, and then maybe removing or changing NA values, kind of stuff that you would need to do for an analysis. And then the next stage of this would be the analytics step, in which you're trying to turn data into insights, or possibly, And while we aren't going to discuss modeling or hardcore modeling in this class, we will discuss data visualization that you could imagine would be associated with some sort of model building process here, and we will create different data visualizations and discuss it in detail. But like the purpose of those discussions won't be to answer any sort of like interesting question, although I will discuss interesting findings as we go, because it's just natural to do so, and I'm sure that when you're watching the videos, you will too. Okay. All right, so now the tidyverse at a high level. So the tidyverse is a collection of R packages which are explicitly made to work together in service of data scientists and data engineers. And in the tidyverse, these are, I would say, well, David says it, and I agree with him, that these are the 5 most important packages in sort of what I do in statistics. I guess what David does as well. Okay, so these packages are and I'm going to go. Okay, let's go in order of this sort of pipeline here. So we have reader, which is going to import data that exists somewhere into R. Then we have Tibble, which is the data object itself. I would say tidy R, which does high-level reformatting to make the data tidy. And then we have dplyr, which I would say is this arrow right here. Well, I guess so is tidy, but dplyr really is the workhorse for subsetting data sets, rows, columns, creating new variables, stuff like that. And then last but not least, last and certainly not least, ggplot2, which is in this analytic category, which is useful for mostly for visualization. And I say mostly because you can do some modeling under the hood, but it will be in a context of visualization. Okay, which we'll sort of talk about a little bit in the video on ggplot. Okay, so these are the 5 main packages. A little bit more on ggplots on 2 directions. One, it doesn't really have, I would say it doesn't really have competitors with other programming languages. This is a great package for data visualization. And I would also say, and I would also add that it is much better than plotting in base R. So as we move, so, you know, technically tidyverse is like a different way of analyzing data than what you can do in base R. Sorry, I should say tidyverse is a different way of importing, transforming, and analyzing data than what exists in base R. And the comparison plotting in base R is extraordinarily cumbersome in comparison to what you can do in ggplot. And if you've seen it before, once you watch the video in ggplot and, you know, just take even like a short dive into it, that should be almost like readily apparent if you've worked with R before. Okay, so that's it on the slide deck. Let's go to, just one sec. Okay, sorry. I'm gonna pull up a new window here and go with the course website. Okay, just to point to this additional reading section here. This is kind of useful for describing Tibbles. So we're gonna work with the basic structure in the tidyverse. Okay, well, first thing that we need to do is call library Tibble. Okay, you know what? We're not gonna do that. Okay, we are going to first, you need to install tidyverse. Oh wait, I'm being silly. It needs to be in quotes. I'm being really silly. Okay, so this isn't gonna do anything for me because I already have it installed. I'm not gonna install it again, but you are going to need to install tidyverse. All right, so library tidyverse. Okay, so we're gonna run it. You know what, I'm gonna restart the session. Okay, now I'm going to load tidyverse because I wanted to, okay, yep, I wanted to show all this. Okay, is my head covering anything up? No, it isn't. Okay, I'm just gonna move it just, okay. Anyways, so attaching, so you get this, so remember print statements, or, you know, sort of the S3 system in R. This is under the hood. When you call the library function, in this case, there's a specific print output for when you call library tidyverse, and it just tells you that it's attaching the core tidyverse packages to your R session. So yeah, actually so that's great that you're prompted to do this, or that it prompts this. And then it talks about conflicts, and these are not error messages. What it's doing is the tidyverse contains a bunch of functions, and some of which may exist in packages that you have installed or loaded into R. It just tells you about that. And what conflicts mean is that there's 2 functions in different packages that have the same name. And so for instance, in stats, the stats package, which always loads in R unless you do something crazy. When you open R, stats is there. So stats has a lag function and a filter function, and when you load into tidyverse, dplyr has both those functions. So it's just telling you about that. So that's very nice. Now, backing up a little bit. So yeah, so as I sort of said, R has a collection of packages in it when you install it. And then there is, and I think I touched this like very briefly at some other video way earlier in the class, where R has a just wealth of additional, just an abundance of additional packages that people have written for whatever task. So like for instance, for research that I do, if I do some sort of new statistical method, then I want to make an R package or R software which has the same documentation, that you can call on with a question function in the same sort of notation or the same style that you see in help packages, as a way to collect, the tools that I make that can assist people in data analysis. So I write R packages to supplement the research I do, certainly write functions, and a lot of other people do too. So there's a lot of packages that exist. Tidyverse is one of such packages, and to get it, you need to install it. And as you install packages in R, and you may install, I don't know, I don't want to guess how many you may install, but a lot of packages, the more experience you get in R. And so R isn't going to load in all the packages that you have installed, so you will need to specify them unless it's like stat or base R, that kind of stuff. Okay, so it's a long-winded story. So we are library tidyverse. Okay, so, and what did it do? We have Tibble, which we're going to talk about, reader, which we discussed as one of the main packages, dplyr, tidyr, ggplot, and others. I mean, I don't want to say that the other ones are useless. I use libradate all the time, and stringer I've used a few times. I don't really use, or maybe I do and I don't know it, but those other ones I definitely know that I use quite a bit. But anyways, the big five is definitely something that we're going to be using. Where did my slides go? Oh, anyways, it's fine. Okay, so Tibbles. So one small aside before we get there. So in base R, there is a data frame called air quality, which I guess you could say is some sort of canonical data frame for communicating concepts that involve data frames that's just built into base R. And you can see that when you load it in, or when you print it, the printing is not very useful. I mean, you can see that there are values corresponding to some number of variables, but you'd have to go all the way up to the top to get the variable names. And so it's not a very useful description. And, essentially, if you're going to display any data frame that has more rows than what you can display in R, this is what you're going to get. And if it has more columns than what you would can actually view in the window, then it's going to do something crazy where it's going to go here, it displayed 153 rows. It's going to display 153 rows for that initial set of columns that can fit on your screen, and then 153 rows for the next group of columns, and you have to do all kinds of crazy scrolling. So not an easy presentation, but now, just like air quality is a canonical data set for communicating concepts about data frames that exists in base R, there is a, I guess, more fun one in dplyr called Star Wars. And you can see that this is initially looks like a data frame, but it's a Tibble. It says it's a Tibble. It also gives you the dimensions of the Tibble right away. There's 87 rows and 14 columns, or there's 87 observations and 14 variables. Okay, very cool. It displays a little snapshot of the columns that are displayed. So we can see, name, height, these variables, but it also shows some information about the type of the variables right under the variable name. So character, integer, double, character. Cool. Okay. And then it says 10 rows, which you can see. It highlights NA values to alert you that, hey, there's values that are missing. This is all very cool. Tells you that there's 77 more rows and 6 more variables, and it gives you information about those variables. And then you can, print more if you want. Okay, cool. All right, just a sec. Okay, so let's see here. So I can use Glim, Star Wars, and oh wait, what am I doing here? No, I don't want to do that. Sorry. I want to, okay, first I can also display air quality, the data frame, as a Tibble. So remember, air quality is this 153 rows, very hard to see, but I can convert it to a Tibble. So I guess at a high level, you can think that a Tibble is a data frame that has a specific additional structure to it, which is now being leveraged in order to print out or display information to you in a much more convenient way than what data frame in base R actually does. And stepping back from that high level, getting more specific, we can actually see that although air quality is a data frame, that's what its class is, a Tibble is also a data frame, but has these other additional classes which are actually doing the task of what I just said, which allows it to be printed in a way that's more readily interpretable, I guess, has more information about it. Okay, so how can we, instead of working with the stock Tibble or converting some data frame that exists into a Tibble, how could we just make a Tibble straight from scratch? Okay, so we can do the exact same thing that you would do in base R with data frame and just specify variables directly. So remember, okay, so we're doing a tidy data structure. We have variables, we have observations, and we have individual cells. So I'm specifying the variables, and it's going to have a consistent number of observations for the variables. And I may leverage recycling. So if I want to do the integers from 1 to 10, and I want to do hello, we can see that this is going to display as a Tibble. And hello exhibits some, in order to create it, there's some recycling going on. Okay, so now if I want to do something like this, it's going to complain. So the tidyverse Tibble and the tidyverse can be rather finicky and complain about a lot of things. So this one is not going to allow you to do recycling for any object with length greater than 1. So we actually can get around this in a number of ways. One way is to realize that that's going to happen and specify a rep function. So there's 2, this is a length 2 vector. I'm going to repeat it 5 times. Okay, and that gets the recycling that I would want. Another, and this is, I don't know, maybe this is a poor form hack, but I'm going to just do it. Data.frame, and then as Tibble, and that's just the same thing. So I could just leverage the type of recycling that exists in R and then just convert the thing to a Tibble to get the nice presentation. Okay, so so if I were to do the data frame itself, this is obviously going to be class data frame, but the as Tibble on top of the data frame will, convert it into a Tibble. Okay, great. Okay, so that's very interesting. Okay, so now subsetting. Let's do, to make it a little bit easier to type, we'll call data frame. We want to highlight the differences between data frames and Tibble. So we'll take our air quality data frame, call it data frame, and then we will do Tibble as Tibble air quality. Okay. So now let's look at the first 5 rows of each of these objects. Okay, So we've seen this before. This is just basic subsetting. Here, you get a very similar form of subsetting. A subset of a tibble is still a tibble when we subset the rows. When we subset the columns, things differ slightly between data frames and tibbles. Okay, so normally the one, as we've seen before, the single square bracket is type preserving, except when we did this row column subsetting inside of a data frame. Here we get this, I think it's, type, an integer vector rather than a list. Okay, so however, in the tidyverse, the tibble, if we look at the column, we get something that still has that's still a tibble. So so it's just a subtle difference. So I guess you have type preservation with subsetting on both rows and columns in the tidyverse, and you don't with data frames. So one slight difference there. Another difference is the following. Okay, so let's say that I want to create some integer vector, and then I want to then make some function of it and store it as another value. Okay, well, R is going to complain. Because what this is doing is it's not actively storing X anywhere in the global environment, which I have hidden from view. It just has these two things, data frame and tibble. Is that right? Yep, that's right. Okay, so then, right, so it's not actually creating a variable X that is accessible. However, through magic that is beyond the scope of this course, Tibble does do it. Okay, so I know I say it's magic beyond the scope of this course, but in tidyverse, as we get into it a little bit deeper, we're going to see stuff where you can do manipulations to variables by referencing their names directly inside of like functions, specifically within the dplyr package. And so like you can call a variable name directly and say I want variable squared. And so I guess the magic internally inside of Tibble is doing the exact same logic that with X specified, I know that I want to create a Tibble with X and I want to access it right away to create Y, and tidyverse is just naturally sort of equipped to think of things that way. Okay, what happens, just out of curiosity, would this work? Yeah, that's what's happening, and it's doing it in order. Yeah, I thought so. The order would be important. Okay, so anyways, very cool. So that's a good thing. You know what? I'm just gonna write it down so we don't forget it. Okay, so this does not actually work. The magic is not, maybe magic, but it's not smart. Okay. All right, great. So let's look at the different types of meta information about these separate objects. Attributes, data frames. We have variable names, I guess, class, and then row names. Okay, and then attributes. So very similar. I guess the order of these things are different. Row names is the same. Class, as we've seen before, it has these other names for, or these different classes that are also associated with a with an object of type Tibble, or of class Tibble. But we can see that at the end of the day, data frame is also a common class among both data frames and Tibbles, so that we do want to think of these Tibbles as not like very fundamentally different than what a data frame actually is. Okay, so one difference here. Okay, so row names, as we saw, they're going to be exactly the same. I can't, what's the way to, how would I do, okay, so what I want to do is extract the row names and reassign them to something else. Doesn't allow for that to happen. Okay. But I can do that, I think, with data frame. Oh, it's only gonna, okay. Instead of doing that, because it's complaining that I'm just using A 153 times, which makes sense. Let's do 153, set equals this. Okay, so I did just change the row names. Now, yeah, let's just look at the attributes again. Yeah, so here's the new row names. Okay, so Tibble doesn't let you mess with the row names. And what I think the reason for that is that Tibble is not a package that exists in isolation of, or that is meant to exist in isolation of other packages. The whole, I guess, let me pull up, let me go back. Normally I work directly from the command line, but let me pull up these slides again. Okay, yes, perfect. Yeah, so these 5 packages are meant to like work, you know, in concert with each other. And of course the other tidyverse packages that, you know, tidyverse loads in as soon as you call the library into R. So I guess a main characteristic of these packages is that they are going to work expecting that the variable names of the object are just are consistent, which will make these packages work in concert with each other. Okay. All right. So another difference is I won't be able to do stuff. Well, wait a minute. Really? I thought that. Wait, what just happened? Oh, I see. Did it not complain though? Let me go back to my document here. Okay, so tables don't support arithmetic operations on all columns. The result is a slightly coerced data frame. Ah, okay. Yeah, okay. Sorry. No, that was... yeah, so I just broke out of the Tibble structure when I multiplied, or sorry, the Tibble class as soon as I did arithmetic operations on it. So if I wanted to multiply all the columns or by some value or add something to all the columns, then Tibble doesn't really like that. Although I would contend if you are doing something like that, then I don't know. That's not something that really happens too often where you're going to perform the same operation on all the columns. But anyways, Tibble doesn't like it. Okay, so let's see here. We should, okay, that's a lot of stuff. If you want to see more about Tibbles, you can see this document, which is just on the course page, Tibble vignette. Great, okay. So just wrap up with a quick summary. Okay, so, right, so as we are switching away from base R programming, or, talking about objects, functions, objects as outputs of functions, we are now going to shift into a more data analysis context, but in this class, we aren't going to actually emphasize any interesting data analysis, but rather develop the tools that are necessary for doing data analysis. And so for the rest of the class, what we're going to be doing is talking about the storage and transport of data. I mean, I don't think we'll go too deep down this more data engineering road, but we'll be loading in data sets. We will be tidying them up and then transforming them in ways to make more useful data sets. And I know that even by saying the word useful, I'm invoking some sort of analysis where I'm trying to do something that is useful for somebody. But really what we need to do is learn the tools, because we want to have a wide range of tools that we're comfortable with, because many different people in many different contexts may be useful, may define useful very, very differently. And then, of course, we will discuss some parts of data analysis, although we won't be doing data analysis. We'll be discussing data visualization, for instance, and developing because ggplot is a massive package. And so we'll cover very, very soon after this, I think the next video, we will scratch the surface on some of the fundamentals of ggplot for visualization, but not necessarily in conjunction with some interesting data analysis, but we'll just show kind of what ggplot can do so that you can learn kind of the general layout and a structure for ggplot that can lead you down the road to produce interesting visualizations for an analysis when the time comes for such a thing. Okay. So that's a lot of stuff. I'm going to stop here. Thank you for watching the video, and take care. All right, bye.